Hello students, I hope you are good, well and fine, and today we will be continuing our discussion of NCERT exercise 1.1 of class 12th chapter 1 relations and functions. So let's solve it. Okay, so we have arrived to a question 5. Let's solve with me. Check whether the relation R in the set of reals defined by R, the relation is defined in this way, is reflexive, symmetric or transitive. So we have to check. So let's see, is it reflexive? So R is my defined in this way. Okay. So for reflexivity, if you recall, we need that A comma A must belongs to the relation R for every A belongs to the set of real numbers. Okay, set of reals. Okay, is this true for any two real numbers in this way? Okay, so this means we know that what we know that A is equals to A, yes, but if you take A as 1 by 10, then AQ, what it will be? AQ will be 1 by 1000, and we know that A is greater than equal to AQ, as you can see. So from this, I have a pair 1 upon 10 and 1 upon 10, this pair which does not belongs to the relation R. And from this, I can say that there exists A from the real numbers such that A comma A does not belongs to R, which means this is not my reflexive relation. Okay. Yes. So this pair 1 comma 10 does not belongs to the relation R. As you can see, A and A cube is this, and we know A is greater than equal to, from here you know that A is strictly greater than A cube, but this does not happens. But if the A comma A pair is in our relation R, then it must be satisfying this condition, but here not satisfying the condition. Okay, so this means this is not our reflexive. Okay, so this is not reflexive. Now let's check for symmetric relation. For symmetric relation, if you recall, what that A comma B and B, if A comma B belongs to R, for symmetric, if A comma B belongs to R, the relation R, I am talking about the relation R, not the set of real numbers, relation R, then B comma A also belongs to the relation R for every A comma B in real numbers. Yes, and for not symmetric, what we need that there is at least one pair AB such that AB belongs to the relation R, but B comma A does not belongs to relation R. So let's see what we will have. Is it symmetric or not symmetric? Okay, so as you can easily see, what that take 2 and 9, take 2 and 9, then this pair, does this pair belongs to R? Let's see. 2 is less than equals to 9 cube. What is 9 cube? 9 cube is this pretty huge number. Okay, so this is true. So this means this belongs to the relation R. Yes, it is true. But if you try to see the 9 comma 2, let's see, does it belongs to the relation R? Let's see. So 9 is less than equals to 2 cube. 2 cube is 8. Does this true? Not true. Yes, not true. So we know that 9 is not less than equals to 8. So this means this satisfy this condition that we have at least one AB which belongs to the relation R, but the B comma A, the 9 comma 2 does not belongs to the relation R. So this does not belongs to the relation R. So from this I can say that it is not symmetric. So it is not symmetric. Okay, I hope this is clear to you. Okay, now what? Now let's check for symmetric relation. Sorry, for transitive. So for transitive, if you recall that A comma B, for transitive A comma B, okay, for transitive A comma B belongs to the relation R, and B comma C also belongs to the relation R, then A comma C belongs to relation R for every A, B, C in the reals, then we say that it is transitive. And for not transitive, there is at least one AB belongs to R, AB belongs to R, and BC belongs to R, relation R, but C comma A, but A comma C does not belongs to relation R. So let's check, is this going to happen or not? So as we know, what we know, that 2 is less than equal to 3. Yes, we know. And we know that it is 3 is the cube root of 3. So just take this. So cube root of 3. So cube root. So this means A is my what? 2 and B is my what? 3. So 2 comma 3 belongs to R, the relation R. So I hope you are making some observation that I have took such pair, such numbers which satisfy this condition. Accordingly, then I choose what will be my A and what will be my, so B will be cube root of 3. Okay. Now accordingly I will choose B and C. So we know B is cube root of 3. Yes, B is cube root of 3. Okay. Okay, so I think let's take another B, as you can understood easily. I'm taking this as what? 26, this as 27. You will see why I am taking these numbers. Okay, so 26 is less than equal to 27. It is true. Yes, indeed it is true. We know 27 is 3 cube. Yes, that's why I have took this 27 number, because it is a cube of an integer. So 3 cube is 27. Okay, so this means my A is what? A is my 26 and B is just 3. Okay, now I can say that 26 comma 3 A comma B belongs to the relation R. Okay, now what? Now as B is my 3, this means 3 and I know that 3, what? 3 is less than equal to what? The number 25. Yes, the number 25. And from this, what I can say? From this, or you can also say that what you can say, that it is 3 is less than equals to, okay, the 25. Okay, 25. Then this means the cube root of 25 will be my what? Will be my C. Yes, C. So from this I can say that B, if B is 3 and C is cube root of 25, then the pair B comma C, B comma C, B comma C will belongs to the relation R. Yes, because because B is less than equals to C cube. It is true. Yes, it is true. So we have what we have, that AB belongs to AB. We have AB belongs to R, BC belongs to R. If you try to see that AC, does AC follows this? Let's check. A is my 26. Is less than, is A 26 is less than equals to C cube. C cube is what? C cube is 25. Does this true? No, it is not true. So this means AC does not belongs to the relation R. So from this, as you can see, that it is not transitive. Why? Because there is at least one AB belongs to R and BC belongs to R. As we saw, AB belongs to R and BC belongs to R, but A comma C does not belongs to R, as A comma C does not belongs to R. So from this we can say it is also not transitive. So it is neither symmetric, reflexive or nor transitive. Okay, I hope you understood it. I hope you saw some observations that from where I have started are A and B. First of all, I took the inequalities, then I choose accordingly that what will be my A, what will be my B, and accordingly I chose what will be my C. And then from that position I concluded that A comma C pair does not belongs to the relation R. I hope it is very clear to you. Let's move to next. Okay, let's move to next. So as we saw that nothing. Okay, so neither reflexive nor symmetric nor transitive. Let's move to the question 6. Question 6 says, show that the relation, so the relation R in the set, so this is my set. Let's say it is A, so R will be my subset of A cross A. Given by this is my relation R is symmetric but neither reflexive nor transitive. So for symmetric relation, if you recall, first of all let's show that it is symmetric. So for symmetric, we know if A comma B belongs to R, then B comma A must also belongs to the relation. We are talking about relation R. Okay, for every A comma B belongs to set A. Okay. So if you see, take any two AB, suppose this. Okay. Or another way to see this definition is this, that whenever A comma B belongs to the relation R, whenever A comma B belongs to the relation R, then B comma A must also belongs to the relation R. Okay, so from this is quite easy. So just pick any element from here. So R, in R the pair 1 comma 2 is there. So 1 comma 2 is belongs to R. Does 2 comma 1 belongs to R? As you can see, yes, indeed. 2 comma 1 belongs to R. Now picking this 2 comma 1 belongs to R, this means 1 comma 2 must also belongs to R, as you can see. Yes, indeed. So this means it is what? It is symmetric. So by definition, I can say that it is symmetric. But for reflexive relation, pick any element in this set. 1 comma 1, does 1 comma 1 belongs to R? No. So I can easily say that it is not reflexive, because for reflexive relation we need A comma A belongs to the relation R for every element A in the set A. So here the 1 comma 1 pair not belongs to here, but we need that 1 comma 1 must be in this relation set. So by definition, I can say that it is not reflexive. Similarly, for transitivity, we know whenever A comma B, B comma C, so for transitivity, for transitive relation, whenever A comma B and B comma C belongs to R, then A comma C must also belongs to R. If this happens, then the relation is transitive. If this doesn't happen, then my relation is not transitive. So let's see. 1 comma 2, 2 comma 1 belongs to R. Yes, but 1 comma 1, from this definition, 1 comma 1 also belongs to R. But as you can see, 1 comma 1 is not in the relation R, so it contradicts the definition. So from this I can say that it is not transitive. I hope this is clear to you. Let's move to next question. Now, show that the relation R in the set A of all the books in a library of a college. Okay, so my set A is all books in a library of a college. So my relation R is defined in such way that pair of two books X, Y such that X and Y have same number of pages. Is this equivalence relation? To prove that it is equivalence or not, we need to show that it satisfies the reflexive, symmetric, transitive. If satisfy all of these relation type, then it is equivalence. If fails to satisfy either one of it, so it is not equivalence. So let's check. So reflexive. So for reflexivity, this means X comma X belongs to R. So let's see, does X comma X belongs to R? To show X comma X belongs to R. So as we know, X and X have same number of pages, This means from this I can say that X comma X belongs to R by just straightforward statement. Okay, so it is reflexive. Now what? Now symmetric. So for symmetric, what we are given with? We are given with A comma B belongs to R, the relation R. Then what we need to show? To show B comma A belongs to the relation R. Okay. Now what? Now, if you try to see that we know what we know, if A comma B belongs to the relation R, this means A and B have same number of pages. Okay. From this, what I can say is B and A have same number of pages. Yes. And from this I can say that B comma A belongs to R. So we showed that B comma A belongs to R whenever A comma B belongs to R. So it is symmetric also. Now let's check for transitivity. So transitive. For transitive, what we are given? we are given A comma B belongs to the relation R, B comma C belongs to the relation R, and to show what we need to show? To show A comma C also belongs to the relation R. So let's show. From these piece of information, what I can say is very clear that if A comma B belongs to R, this means A and B have same number of pages. Okay. And from this, what I can say is B and C have same number of pages. Same number of pages. If A and B have same number of pages, this means if A have 100 pages, then B must also have 100 pages. And from this, I can say that if B have 100 pages, then C must also have 100 pages. So from this, I can easily say that A and C have same number of pages. So this implies A comma C belongs to relation R. So I have showed that it is transitive also. So it is reflexive, symmetric, transitive. This means our relation is an equivalence relation. Okay, our relation is an equivalence relation. Okay, let's move to the next question. Now, question 8, what it says? Okay, so show that the relation R in the set A, so this set is given to me. R is defined in this set. R is defined in this way: A comma B, such pairs such that the difference, the modulus of their difference is an even number. Okay, so what we need to show? That it is an equivalence relation. So to show that it is an equivalence relation, we need to show it is reflexive, symmetric as well as transitive. Let's show it. So for reflexive, what we need to show? To show A comma A belongs to the relation R for every A belongs to the set A. Okay, now what this means? If you take any let A belongs to the set A, this set, and from this I can say then A minus A, what it will be? It will be 0. Yes, and if you take this, imply modulus of A minus A, what it will be? It will be 0, and we know this is what? Even. So this is even. So from this I showed that it is reflexive. Why? Because A minus A is equals to 0 and 0 is an even. Okay, so this means A comma A belongs to the relation R, as this is satisfied. A minus B, which is A minus A modulus, is equals to even. Okay, now for what? For symmetric. Now for symmetric, given what we are given with, we always given with in symmetric that A comma B belongs to R, and what we need to show? We always need to show in symmetric that B comma A belongs to the relation R. Let's begin. So if A comma B belongs to R, this means A minus B, the modulus of A minus B is equals to some even number, some even. Okay, now this means that what I can say is, we know what we know. If you recall what, that modulus of A B, what it will be? It will be modulus of A modulus of B. Yes, or from this I can say minus of A is equals to the same as modulus of minus of A is same as modulus of A. Okay. For example, minus 5 modulus will be equals to modulus of 5, because this answer will be 5 and the output will be 5, and both the output will be equal to each other. Okay, I hope this is clear to you. So from this, what I can say is this, that it is very quite clear that b minus a is same as minus of a minus b. Yes, and we know that what we know, so b minus a is same as a minus b, and we know from this that minus 1 times a minus b, and minus 1 modulus will be 1. So 1 multiply mod of a minus b, which will be mod of a minus b, which will be even. And from this I showed that b minus a modulus is equals to some even number, and from this I can easily say that b comma a belongs to the relation R. So from this it is also symmetric. Okay, now let's talk about transitive. Okay, so for transitive, what we are given or to show what we need to show always, a comma c belongs to the relation R, and we are always given with a comma b and b comma c belongs to the relation R. From this I can say that a minus b modulus is equals to even, and from this I can say b minus c modulus is also some even. Okay. Now as you can see, what you can see is quite easy, that a minus b, when you open modulus, if you recall, mod x means what? X, if x is this positive, and minus x if x is negative. Yes, so you can break into two part like this. Okay, so or okay, I hope this is very clear to you. Now what you can say is this, that if a minus b mod is even, then a and b both must be even, because even minus even will be even. Yes, or let me use blackboard. So a minus b is even, imply a and b both are even. Yes, because both are even. Why? Because even minus even is equals to even, or a and b both must be odd, because odd minus odd must be even. Yes, odd minus odd will always give even. Okay, and same with the case of b minus c. This implies b and c both even or both odd. So if you pick this condition, a and b both are even, then what you will get? This or this condition? You will get this condition. Why? As we already saw that if a is even, then b must also be even. So from this I can say that if b is even, then C must also be even. So this means all are even. So we know, so A and C are even. A and C both are even. This implies A minus C must also be even. Okay. If you are lying in this condition that A and B both odd, so if A and B both odd, this means B is odd. This means if B is odd, then C must be odd. So this condition will follow. This means C must be odd. This means A and C both must be odd. So from this I can say that A minus C, odd minus odd, you will get even. Odd, if you know, odd number you will get is something like this, 2k plus 1, and another odd, you can say that 2k1 plus 1. If you subtract them, you will get even number. Okay. Okay, so from both of the possible cases, we arrived that A minus C, mod of A minus C will always be even number. So this means A comma C must belongs to the relation R. Or you can say, also see that 1 minus 3 you will get odd, 1 minus 5 you will get odd. Take any two odd numbers, you will get even. Take any two odd numbers, you will always end up with what number? Even number. And pick any two even number and subtract them, you will always end up with even number. But if you pick odd and even, you will get as the difference as odd number. Okay, so but here the condition already given that we want even number. The modulus we want is even number. So from this it is transitive also. So it is an equivalence relation. Okay, I hope this is very clear to you. And this part I leave to you, that you can easily solve it. Okay, so here it is quite easy, that what they are saying, that 1, 3 and 5 are related to each other, as I already showed that the odd numbers will link to each other. Why? Because of these conditions as I have written down. And even are related to each other. Okay, so 1, 3 and 5 related to each other, the set of odd numbers from A, the set of even numbers from A. And if you try to link the set of 2, 4 to 1, 3, 5, you cannot find anything. Okay, so I hope you can do the rest of it. So thank you. That's it for today. We will meet again. Thank you.